The next part to model is the adjustment screw, and it's a lot like the dial. We're going to model it pretty much the same way by drawing a sketch on the XZ plane. I'll first activate the body and start a sketch, and I'll turn on that section plane tool so we can kind of see through or see the relevant area to work on. And I'm going to do the same thing again. I'm going to draw the top edge in two parts and the bottom edge in one, and this time the bottom edge is going to be directly on the x-axis. Make sure that these 2 points are coincident, and I can set the horizontal length constraint on this. I think it's 2.5 inches. And the threaded part is going to be 2 inches, and the height on it is 7/16 of an inch. I'll set it at 7/32 for the radius, and then it'll revolve around that x-axis. And we'll set these two to be symmetric as well, and that'll constrain it, and then we can do the revolve around that x-axis. The next thing I need to do is cut the keyway in the circular face, and for that I need a datum plane that's tangent to the surface. So I select the edge on the end and do a datum plane normal to edge and set the roll to 90 degrees. You'll see that puts it on top, but I want it on the front. So you can use this map path to parameter property, and it takes a value between 0 and 1. So if I play with this and I set it to -25, that puts the datum plane on my front face, and then I can use that as the basis for a sketch to draw out the pocket that we'll cut in for the slot. So it kind of rotates around, and I got to play with this to get it in the right orientation, and it's easier for me to just turn off the tip of the body, so I'm working directly on the datum plane. And then it's just a matter of sketching the rectangle. I'll set these 2 points to be symmetric. I don't know why all of a sudden it has started doing that. The first time it seems to eat my constraint. I do the same thing again, and it sets it symmetric. Alright, I'll set the horizontal length to 1.5 inches, inch and a quarter. And the width on this is 1/8 of an inch, which is also going to be the same depth that we pocket it to. So I'm constrained. I can close this. I'll turn the tip back on, and then we'll pocket, and this has to be reversed so it's cutting in, and set this again to 1/8 of an inch. Alright, that should be the screw, and it'll look like that. So next up we're going to model the bolts, the clamping bolts. And these are pretty straightforward. It's I'm just going to model one, and then we'll mirror the other one. So I'm going to select this edge and do a shape binder on it, and then we'll use that shape binder to establish a datum plane that we can sketch on. But let me turn these off so we can see, and set the datum plane, and then I need to get a reference to that circle. So reference to external geometry, where is it? Let's do the sketch. And then I draw a circle that's with the origin locked to the center point, and set them equal in size. That's all there is to sketching the main part of the bolt. I'll reverse the pad direction and set the length to the length. Now this is going to be the threaded part of the bolt. So it's 23/16. I'll turn off the shape binder, and now I can use the top face, and I can draw a sketch on this. This is going to be the shoulder flange on the bolt, so it needs to be centered on the center point, and then bigger. It's actually it's this is cut from a 1/2 inch stock, so it's 1/2 inch diameter, and then padded out to a 1/16 of an inch thick. And then sitting on top of the that shoulder is the squared head. And square is very easy to draw. You just use the square tool, and then you can select two diagonal points and the center point and use a symmetry constraint, and that will center your square around that point. And then setting two edges to be equal, keep it square in both directions. Now the actual dimensions on this are 3/8 of an inch, so I'm going to input that, and you see that our corners are actually wider than the shoulder, and that's going to cause us a bit of a problem. But I'll close that, and then I'm going to pad this out to 3/8 of an inch high. The reason I say that that's a problem is that if I were to chamfer those now, OCC would actually crash because it doesn't like that kind of a chamfer. And so I'm gonna cheat a little bit for the purposes of the sketch, and I'm gonna make my the edges of the square less than 3/8 of an inch. I'm gonna bring them in so that they're just inside of the radius of the circle. And now I can select those edges and apply a chamfer to them, and OCC won't crash on that. And that's our basic shape for the bolt. Let me turn on the base object, some of our other objects in here, so we can see. And now I'm going to mirror this bolt and create the second one, the clone. You can't use the part design mirror. That's for mirroring features within one solid. So I'm using the part workbench, and I'm going to mirror across the YZ plane. And that gives me the second bolt, and it just nests it underneath the object in the tree. All right, let's go ahead and add one more, and we'll add one more body, and we'll model the little set screw. And so I've created a body and rename it to set screw to keep it organized. And I'm going to select this outside edge of the hole and do the same thing again. I'm going to create a shape binder in my new object, and I'll turn off some of these other objects so we can kind of see what we're working with, and do the datum plane so I've got something that I can sketch on. Again, this is just a little bit visually noisy. It's hard to see what's actually going on here. Turn off the other bolt. Now I can see that circle. I'll get the reference to the external geometry, and then draw a circle with the center locked on it again, and make the circles equal. I'm not sure if that's quite right because this is a threaded hole, so that set screw needs to be a little bit bigger than the hole, but I can revisit that if it's not right. Okay, I'm going to pad this out, inverting the direction, and now I'm going to select the end of the cylinder, and we're going to do a sketch on it to create the hex head. And we can just use this polygon tool, which draws a circle for the control geometry. We'll set the center there, set the radius, make sure the top edge is horizontal, set the actual diameter of and I don't know exactly what the diameter is. I'm kind of faking on this one here. This is mostly for looks. You really only need to model things that you're actually going to use, and so I'm just kind of modeling this to give you a sense for how it would work. We'll set the depth at about 0.1. That looks about right. And now the other end is this dog point where he turns the screw down to 1/8 of an inch to fit into that keyway. So I'm going to draw, and I'm going to pad that out, and so I'll set this to 1/8 of an inch. And yeah, see, it's the same. It's the same diameter as my screw. So if I pad this out to 1/8 of an inch, which is the depth of the keyway, I need to go back and revise my the diameter of the main part of the screw just slightly. So I'll take off that equality constraint. It's sometimes hard to click on them, but you can always get to them in the task panel. And then I'll give this a diameter. Instead of being 0.2, we'll set to 0.15, or instead of 0.18, 0.15. That looks a little bit more like the set screw. Turn our base object back on so you can see how it would fit in, and then how it would fit into the adjustment screw. I probably don't have the length quite right, but it gives you a sense for how those pieces fit together. We'll turn on the bolts, and that should do it. Hope you found that useful. If you did, let me know. Leave a comment below, and I will look at doing more of these kinds of things. Big thank you to Mr. Peterson, Mr. Pete 222. Great stuff, and you know, I hope you don't mind me using this as the basis for a project, and like to do more of it. All right, see you in the next video.